This is a video that I'm going to be making about how the LED module works. Now this code over here on the left is the code that's actually uploaded to the module itself. This code over here, on the other hand, is what's actually running the module. So it's actually the code that's uploaded to the master that makes the LEDs do what they do. So first we're going to start off over here with this include wire.h statement. This actually includes a library that it's actually essential to transfer data over the I2C bus, which this does. The next one here are two variables that we're going to be declaring. These are byte pin and byte state. So the byte pin, what it declares is just a value that says whatever the pin number is. That is going to be changing, and the state is what state that pin is going to be. Then in void setup here we have three things. We have wire.begin on 4. This starts the two-wire interface, or I2C, on address number 4. This is for communicating between the master and the slave. This is the address and kind of like a port that they use. Then we have a wire.onReceive receive event. What this does is it actually, whenever there's new data on the wire or I2C bus, whenever there's data there, it does whatever this function is. So in this function, in this case, the function is receive event. This basically tells whenever it happens, it goes to the function receive event, which is actually down here. We're not to there yet. We have to go to the for one first. So basically what this says, it says int I equals 2. Now this says the starting value for the variable I, and then basically the I is less than 12. That goes between number 2 and number 11. So, and then basically it just takes whatever pin that is and makes it an output. So it goes between pins 2 and pins 10, between pins 2 and 11, and it makes those all outputs. So we know they're all LEDs, and they're all going to work for this project. And in void loop, notice that it does absolutely nothing. Now this is actually because it doesn't need to do anything, because this on receive is actually an interrupt, which means it stops the Arduino from doing anything, and then it actually goes down to here to do whatever is in void receive event. So the first thing we're going to do is declare pin equals wire.read. Now what this does is it reads 1 byte of data from the I2C bus, and it actually puts that value to the pin variable. And then we take the state and we actually assign that to wire.read. That means it actually reads the next byte, and that's the state. So it reads the first byte, it's the pin number, the second byte is the state. That's all the data that's going to be transferred to it. And then we say if the state is not 1 or 0, which is what this is. If the state is not 1 and the state is not 0, then it doesn't do anything, it returns. Because return is basically the Arduino's fancy way of saying, get out of the function, don't, stop what the function is. Then it'll actually go back and doing nothing in the void loop. So it actually stopped the interrupt and actually not do anything. And then it digital writes the pin to the state. State to the pin, I should say, because then it takes that pin variable that we assigned before and the state variable and actually just digital writes them to the LED, and that's all the code that happens over here. Next, on the other hand, we have this. This is the down the row code, which basically makes the LED go down the row like we saw yesterday. So we first have to include the LED module library that I made. Basically, this is the library responsible for setting whatever LED to whatever value. Basically, the function is, and then we have LED module, my LED module. This actually assigns a LED module object so the Arduino can actually reference it. This is important because otherwise it would not have an LED module. It has to actually begin the system, which is actually what this does here. By beginning the system, I mean start the communication to the device. And then in void setup, it does nothing because it doesn't need to do anything. Then in void loop here, you see a for loop that repeats 10 times. It goes from 1 to 10. The less than means it's actually less than 10. It's actually less than 11, which means it's 10. Because you can't have 10.5 because it is an integer. So then it makes I more every time. So basically just counts 10 times from 1 to 10. and then it goes the LED of I, which is actually the pin number that it's set to right now in the for loop, and it says whatever that is, it turns it on. And then it actually does if the I is greater than 1, that means basically most of the LEDs, it actually takes the LED before it and turns it off. That it was actually lit up previously, turns it off. But because there's nothing before number 1, we have to make sure that it's if I is number 1, we have to turn off number 10. Because otherwise LED 10 will always be on because it always goes back to the beginning and then always leaves number 10 on because we don't have an LED set to pin 0. Which is okay because we don't actually need one to be set to pin 0. And then basically what we do after that, we just delay 200 milliseconds. That means it changes 5 times a second. So that's basically all that happens in the LED module library. So you can actually see here that these LEDs are going like that, like we set the code to do. So it actually goes down the row of LEDs and lights them all up like that. Now this is actually the master, acting as the master right now, the master module. So basically, just don't be too scared because this is just an Arduino right here, an Arduino Mega 2560. I could have used an Uno like this, but I didn't because I had this lying around. And I mainly use this for programming this because this is just an 18 mega right here on a breadboard, which is not very useful as it is, because you can't actually program it directly from USB. So I basically use this 18 mega 32U4 right there to interpret the USB and convert to serial for the Arduino to actually understand. So basically that's all that's happening when you program this. And that concludes the LED module update video, so stay tuned for more videos on future modules. If you have any suggestions, leave them in the comments below. I will be reading those tomorrow, so just put those down there and I'll be able to read those suggestions for new modules. We already have LCD module to use this LCD display as a module, so we can actually send data to this. We also have button module. There's a basically, here's the prototype right here. Basically it has 8 buttons. I'll be explaining, I haven't actually finished coding this. I'll be explaining it in the next video, so stay tuned. So if you have any suggestions besides LCD module or button module, leave them in the comments below. I'll be reading those. Thank you all for watching, and see you all tomorrow.